Okay, so in the first video you were like translating expressions and doing stuff like that, and then just reviewing some of the basics about multiplication and exponents. So they're putting that in here so that when we come to some of these evaluating expressions problems, you're good to go. Now I always like to point out that hidden in the word evaluate is the word value. Now of course they don't have the E at the end of the word value, but what is something worth to you? So if you have a $100 pair of shoes and then you end up scuffing them up, maybe they're only worth $90 now. So something has a value. And what this really means is that as we evaluate these different types of problems, then by the end of them, we're going to know what is this whole quantity. And notice what your word I use there, quantity. What is this whole quantity equivalent to? What is it the same as? Now, they put these parentheses in here. Now, it's not like there's some evil math demons that are hanging around putting parentheses in things, but it's really kind of just to mess with you. And so the first thing I'm going to point out is that if I have a parenthesis here that gets opened in front of the 2, it gets closed. And if I keep on moving, I have a different parenthesis that's opened, and then I have -4. And then that parenthesis gets closed as well. And notice the direction that they're facing. It's subtle, but it's not, too hard to see. Now, I have a new parenthesis get open, and that has the -8. But you'll notice that the next parenthesis is open as well, housing -3, and then finally closing in. So notice that the ones I put in black here are the same right there, and then green here and here is the same right there. Now notice that I didn't say that this is in red and not to write it or anything like that. Maybe you wrote it, maybe you didn't. Maybe you got colored pens because you were so excited by the dynamic changes happening in front of you. I bet you'd be a little bit flexible, okay? Now, I'm going to look at this and I'm going to see something as 2 times a -4. There's no reason that I can't do that in this first step. So the quantity 2 times -4 gives me a -8. Because a positive times a negative is a negative. But then in this parentheses, and just for now, I will make it match this green color. I can do -8 times -3 to get +24. In red, I'm going to write what happened off to the side. That's -8 times -3. All of that was in these green parentheses. But if I would have just shown you this problem, you'd be like, oh, that's fine, I can do that. But suddenly it looks kind of complicated. So if you're a computer programmer, this would be totally natural to you because you'd be familiar with these parentheses and how they work all the time. Now, you're working on evaluating expressions, and you're working on algebra and all kinds of stuff like that. So if you can't do 24 times 8 in your head, you shouldn't. And if you can do it in your head, but it slows you down, you still shouldn't, because you want 100% of your attention focused on the higher level of math whenever possible. Now maybe you're like a king of being like, well, 4 times 8 is, 32? And then 20 times 8 is 160, and I can put 160 and that together to get 192. That's cool if you can do it quickly and not slow yourself down and miss out on the problem. Now, we're presented this evaluating each. This is all numbers. But over here I'm presented it in words, but I can't forget that the instructions were to evaluate each of these. So we have to make sure that we're good there. So there's an in-between step that wasn't even told to us, it's just implied. So if I have the number 4 and I wanted to cube it, well, it's not like a square when I did area problems and I would do like 4 times 4 and get 16. A cube has the third dimension. So this would be 4 to the power of 3. And I really can work my math out to the right here, but everything in most of my style is going to be to do the problem vertically. So in my head I know this is 4 times 4 times 4. 4 times 4 is 16. Times 4 is 64. But if I can't spit that out, then I'm pulling out a calculator and I'm looking for that whole, YX button or however it looks. Typing the number 4 first and then the 3. So hit me up if you need help with how to use a calculator. Now we got 2 to the 6th power. Well, 2 to the 6th power, 2 to the power of 6. Now we don't live in a 6-dimensional world that we know of, so we don't bother really writing this out. But I do want you to think about this. So we got all this room to the right, so let's rewrite 2 to the 6th. Well, isn't that 2 times 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 2? So if you think of it, 2 times 2 times 2 maybe you can pull that apart in your head as 2 cubed times 2 cubed. And if you can juggle all this, you can be like, well, that's just 8 times 8 is 64. It's really cool being able to do some of these exponents quickly. I wonder if you could figure out why that's the same as that. That would be crazy cool. All right, so evaluating expressions. That's the first sets of problems. Then we got to write verbal expressions next. So write a verbal expression for each algebraic expression. So we're taking something with algebra and turning it into words. Now, if we were working on these problems in class, I would totally just say 4m cubed. I would keep it simple. You never want to complicate things that you don't have to. But for here, they want us to get some practice with this. And it is totally okay to be kind of taking the easiest route on these problems. And the reason I say that is because it would still be accurate. Now, you can't be like 4m cubed, like I said, but if you wanted to say 4 times, that's totally all right. So in red over here, I'm going to show what would absolutely be fine. 4 times, well, then we have an m with an exponent, so maybe like 4 times m to the power of 3. But since these are our notes, we probably want to do a little bit more fancy stuff. So I'm going to think about the fact that multiplication is implied between that 4 and that m cubed. And I'm like, well, that's has a fancy word for multiplication. So I'm going to say the product, P-R-O-D-U-C-T, of 4 and a number, and then usually you see it italicized, but it's not like you bother writing that. The product of 4 and a number m cubed. I would never box something like this. It's words. It just kind of keeps it ugly. And the reason I wrote it out difficult like that is because these are our notes. But I want to go back to why I said it's good to take the easy route. You know, if you end up getting a little bit too adventurous in some of these, you know, you might get way too off the beaten path and end up making something that's just straight up not true, like, or inaccurate. And, you know, then you're going to lose points for trying to be creative. And I'm probably sending the wrong message there because it's good to be creative. But, you know, obviously, you know, like I said, be flexible. You know, if you want to be conservative at times, creative at others. But here, if you want to get max points and it's like assessment-driven or test-driven, then that's kind of a good purpose for being safe. But, you know, what if you were like a caveman? You know, and you never came out of your cave because you're like, oh, I want it to be safe. Oh, I'm scared. There's like a bear over there. Then you would never, like, live, you know. So live your life. But be safe in other moments. All right, so here we got c squared plus 21d. So I'm going to say a number, because I see the letter c, a number c. Well, what's happening to it? Well, it's being raised to the power of 2. But here, brevity, meaning being quicker to the point, is nice. A number c squared, S-Q-U-A-R-E-D. Now, I want to say added to, but I can't. So maybe I adjust and I'm like, well, the sum of, oh, that works left to right. That's totally cool because that's how that sum product quotient difference words work. The sum of a number c squared and 21 times d. Now you could get crazy complicated sneaking the word product in here, all kinds of different stuff. You could have, like, instead of mentioning c squared first, put that down at the end and been like added to or added. So there's all kinds of different stuff like that. Here we got fourth dimension going on. So I'm going to say a number. No, let's start with the fact that it's subtraction. You see the subtraction symbol. The difference of x to the fourth power and the quotient, because I'm recognizing that's division, and I said quotient reads left to right, or in this case top to bottom, y and 9. Now don't dissect or pull apart too much of what I did here and be overly critical. You'd be like, well, here you wrote the number 4. Well, here you wrote out 21. Well, maybe I wanted you to see it hyphenated. Here you wrote out fourth. Some of this corner cutting, it's kind of like you're just getting the work done, getting there, and I think this is all clear enough for all of our purposes. And then once you'd write these down, you could try to do the actual problem that you created, because if you did this problem and you ended up with something different than here, you're probably like, well, I screwed up. So I'm like, well, the difference of x to the power 4, the difference of x to the power 4, and the quotient of y and 9. Oh yeah, that's cool, because a division, a symbol, well, that's the same as a fraction. That's the same thing. I'm good to go there. Problemas de las problemas. I got word problems going on. Okay. Word problems are challenging. A lot of students end up getting to them and they kind of dodge them or just star them and hope that it's one of the ones that the teacher goes through in class the next day. But if you don't have the willingness to kind of plow through some of these, you're never going to learn them, so you got to stick it out. And they're not easy for me, they're not easy for most people. But it's kind of like that grit, that go-to that helps you plow through it. So we got the iPhone X costing $999. On a 2-year payoff plan, each month's payment is $42. Now maybe you're like, oh shoot, well I'm going to figure out how much it costs. Just hang tight, because they don't want us to figure out anything right now. The problem says write an expression that will determine what you will owe after M months. And the purpose of problems like this is it's universal. It's like, well, if I end up starting to pay people or pay somebody back and I don't know when I'm going to pay them back by, well, how long is it going to take over time? Or what will it look like 2 years from now? What kind of a spot will I be, when I have a 4-year-old versus a 2-year-old? Who knows? But the whole idea is, by having an expression, it works for everything. So the variable that we're given is months, and that's why it's chosen the letter M, is because M is a pretty common one right there. Well, on day 0, let's kind of try to figure things out. So maybe I'm like, what day? What month? How much would I owe? Well, if I just got the phone, right off the bat, I owe $999. And in the next month, I want to know how much I owe then. So I would just end up, taking away $42. But what I'm doing is I'm taking away the words, and I'm turning it into numbers, and I'm avoiding going straight to the very end of the problem. And I'm doing some in-between work using real numbers to make this a little bit more easy to process. So in the next month I would have made another $42 payment, and that's going to bring me down to $915. And slowly but surely I would eventually find out what I owed. And I'm going to put 3 dots here, 3 dots here, and I'm just going to use the 10th month because it's nice to multiply by 10, because you get whole numbers and all that. And I would end up owing $579. So those dots indicate that some steps were taken and not everything shown in between. And if I need to extend my table, I'll just throw a line there. Now the whole deal is, you had to start with that $1,000 roughly. Well, you didn't just subtract 42 once, you did it twice, and then maybe 3, 4, but you did that repeatedly. And repeated addition is multiplication, and repeated subtraction would just have to be shown with a minus sign. So 42m. Now once we have this expression, let's check it out. Let's see if that works. I'm going to do this in red because I want you to punch it all in one step into a calculator. And so I type 999 minus 42 times 2, and I did get 915. And if I felt like I could check it out in other scenarios too. But since they wanted the expression, and that's all they told me, I'll put a big box about this, and it's what I owe. And here, I'm not boxing it because that's like, here's your answer. I'm boxing it to kind of make it stand out, like so that our eyes go to it and we know what problem we did. So that maybe come quiz, come test time, and if we have some side work and things over here, we're looking at this as kind of the most relevant, important part of the problem. Based on whatever you've been told or whatever in class, this would be the homework assignment. Now these are notes that you've been taking, and the homework is what we put in our physical spiral notebook, meaning it's got the spiral along the side and the text pages. Now there's a way I want you to do this homework as well, so if there's a video for that, make sure you use it for the first number of examples, and if they're not, you need to be seeking me because I will grade you harshly for not adhering or sticking to the style of my work. It's not enough just to put answers. I want you to do my work a certain way and also achieve a certain degree of accuracy on this. Again, this is the second of 2 videos for the first section of the textbook.